So hello everyone, welcome back to the channel. Today we are going to solve the problem nearest smaller tower. So given an array where each element area represents the height of the tower, find for each tower the nearest possible tower that is shorter than it. So you can took left or right on both sides. Note, if two smaller towers are at same distance, pick the smallest tower. If two towers have the same height, then we choose the one with smaller index. So let's understand the problem. So initially, we are given area I, which is the height of the tower, east tower, and we have to find the nearest possible tower that is shorter than it, either on left side or either on right side. We have to find the nearest possible, whichever is closest, take it. Okay. Now, next thing is if we have two towers which are at same distance, then we have to take smallest tower. And if two towers have same height, then take smaller index. So just don't see this, otherwise it will look complex to you. It is really easy, just a simple approach. Okay. So now let's understand with an example test case what we are going to say. Let's say I am at 4. Okay. So I will say, is there any tower which is smaller than 4 on left? Obviously, there is no tower. It is the first tower only. So I will say, is there any tower which is smaller than 4? Yes, this is the closest and smaller tower. Nearest possible shorter tower. Okay. So I will say, okay, take the 2 index. Done. Come to 8. Come to 8 now. Now 8 will say, is there any tower that is closer? I will say 4. Is there any tower on left, right, which is shorter? 3. So I will say both are at same distance. Now I will say both are at same distance. Take smallest tower. So smallest tower is 3. So I will say take the index that is 2. Okay. Now let's come to 3. Now when I come to 3, I will say what is the smaller tower here? No one. What is the smaller tower here? No one. So I will say -1 because no one is available, -1. Now come to 5. Come to 5. 5 will say, is there any tower that is shorter available? 3. Is any tower that is shorter available? 3. So I will say both tower have one distance. Okay, if they have same distance, smallest tower, I will say both tower has same height. So I will say take smaller index. So smaller index is 2. Okay, so these are basically if else condition that we're going to apply at the end. Okay, just see, just see. Okay, now when I come to 3, I will say there is no closer, no closer. So answer will be -1. So this is the actually the answer. Okay, so what is the brute force approach that you think? Brute force approach that you think that for every point, what you will do? You will start from this index, let's say j is equals to I, and you will say go to left until smaller is found. Go to right until that is while loop, two while loops. And after that, you will check distance 1, distance 2, like these conditions. So obviously it will take big O of n square actually. So, but we have to optimize this. We have to get it in big O of n. Okay. We have to get in big O of n time complexity. So before going to big O of n time complexity approach, let's understand the intuition that what we are going to do within the approach. So let's say, I have 3. Okay. Now I will say, let's start from the beginning only. I will say, let's say I have 4. Now I will say 4, I have any smaller element before? No. Just skip the question currently. Don't think about question. 8 will say, is there any smaller? I will say yes. Here is a smaller 4. So I will say okay. 0, 1, 2, 3. It will say I have index 0. Okay, done. Okay. Let's come to 3. I will say okay. 4, 8. Is there any smaller available? No. Okay. Now I will come to 10. So is there any smaller available? I will come to 3. So one thing that you can see, let's say I have 3. Two cases can arise ahead. Either I can get smaller element, either I can get greater element. 10 is greater than 3, 2 is smaller than 3. So there are two cases, smaller element and greater element. So if somehow I get smaller element, so I will say, if I have previous, let's say greater element, let's say somehow 4, 8, okay. If 3 is greater than 2, obviously previous greater will also be greater than 2 because they are greater. If 3 is greater than 2, so obviously 4, 5, 6, 7, 8, all will be greater than 2. Whatever elements will be greater than 3 are all greater than 2. That means also, if I think about closest element, let's say I want just like think the question like this. Let's say 2 wants give me the closest smaller element. So I will say if 3 can't afford this, so how 4, 8 can afford this? So I will say taking 4, 8 will not be the good choice. So, like, let me repeat this thing. If I have 4 and 8, and let's say 3 comes, and 3 will say these elements are greater. So, if somehow smaller elements come ahead, so if 3 is greater than 2, obviously 4 and 8 will be greater than 2. So, I will say if I want smaller than 2, let's say 1 I require. Okay. So I will say if 3 is not smaller than 2, obviously 4 and 8 can also be not greater smaller than 2. Okay. This is the thing. Next thing, if I get greater element, okay. If I get greater element, let's say 4 and 8 are behind. So I will say what I want. For 10, I want smaller element before. Smaller element. So 10 will say if 3 is smaller. Let's say if 8 is smaller. So obviously 3 is smaller. 3 is smaller. If 4 is smaller than 10, so obviously 3 will be smaller. So that means also I want closer, smaller element. So I will say if somehow any element comes which is smaller than any previous, taking the previous will again not be preferable. Let me tell you this thing again, that if I have, let's say, greater element comes. So if 3 is less than 10, obviously 4 and 8 will also be less than 10. So why should we take 4 and 8 if 3 is closer than 10? Okay. Next thing is if I get smaller element. So I will say that 3 is greater than 2. So how 4, 8 can be smaller than 2? Obviously, greater elements will obviously be greater than 2. Okay. So this is something like the intuition. Like if you didn't get it still yet, just see the approach. You will get it. Okay. Just see the next intuition that I'm going to tell you. Just see. So one thing that you conclusion from this one example is that taking previous greater will be of no use. Why? Because if 3 is greater than 2, if I want previous smaller, is 4 and 8 be less than 2? No, because they are greater than 3. So how they can be less than 2? This is the next thing. Second thing is if somehow greater element come, so whatever 3 can, if 3 is less than 10, obviously 4 and 8 will obviously less than 10. Okay. Like if 4, 8 is less than 10, then 3 is also less than 10 because obviously if you say let's say 10, and if 9 is less than 10, 8 is less than obviously 10. 7 is also less than 10, 6 is also less than 10. This is the thing. Okay. So, so like taking the 4, 8 will be of no use. So taking previous greater is of no use. This is the conclusion. Okay. So like you will get it. You will get it. When I try in the approach, just see what I'm trying to tell you. You will get it. Next intuition is let's say I come to 2. I will take this 2. Let's say I come to 5. So I will say, let's say I have 5. So I will take this 5. Take this 5. Take this 5. Okay. Take this 5. Come to 10, take this 10. When I come to 4, I will say, I will say, now 4 will say that taking this previous greater will be of use. I said no. Why? Why? Because if let's say 6 comes, 6 comes, so that means 6 want the closer, smaller element. This is the let's say height of 6. So I want anyone which is smaller than this. Just take that. So I will say that if 4 comes, so obviously 6 will try to take this 4. So that means taking 5, 10 is no use. Again, if 4 is here and if let's say 3 comes, so I will say that if if 4 is greater than 3, so how 5, 10, which are greater than 4 can be smaller than 3? They are also greater than 3 because if let's say 4 is greater than 3, 5 is also greater than 3, 6 is also greater than 3, 7 is also greater than 3, 8 is also greater than 3. So that means taking the previous greater for both of the cases is of no use. So this is the conclusion. Now next conclusion that I'm going to tell you. Let's see. Just rub this all part to better understand. Now we have two. We have taken 5, we have taken 8. Now we will say that taking 5 and 10 will be of no use. Just remove it from here. So I will say 4 will be here now. Okay. Now 3 comes. 3 comes. Now I will say why I have not removed. I have removed the elements which are greater than 4. Fine. Why I have not removed the elements smaller than 4? You will now realize this. Let's say here 3 comes. 3 will say this element is greater. Remove it. So you can see 2 can afford this. That means taking the previous smaller is always beneficial. Why? Because if somehow you get any element which is less than this, so previous smaller element can handle this. Okay. So that means just the final conclusion is that taking previous greater is of no use. Taking previous smaller will be beneficial always. So these two intuition, just keep these two things in mind and just try to try and the approach. You will get it. You will get it. So let's try to try and the approach. Now, my main task is now previous array will say that find me the index which are smaller than every element. Okay. So I have taken this tag data structure. Now just see this. Dry run. Let's say I come to 4. I will say stack is empty. Yes, that means no smaller is present. Okay, so just take minus one. Just take minus one. Okay, and push this 4 because it can become candidate for anyone ahead. Okay, so just take this 4 inside the stack. Now come to 8. Come to 8. Now we will say 8. Okay, 8. You are greater than 4. So 8 is greater than 4. So I will say this is a smaller element. So what is the index of smaller element? 0. Take this. Take this. And push this 8 in stack. Now you will say why I'm pushing this greater element in stack. Okay. Let me tell you. Let's say 10 comes. 10 comes. Now 10 will say that this 8 is less than 10. So obviously, this is closer. My aim is not to find the smallest element. Just understand, my aim is to find the closer, smaller element. Okay, that means if 10 is here, and if I somehow find 9, just take it. So that means I will store greater element for now. If because it can become useful. It can become useful. But if somehow, just see this. Okay, just see this. Let's say now 3 comes. Now 3 will say, whatever 8 can do, I can also do. If 8 is less than 10, I am also less than 10. If 8 is less than 11, I am also less than 11. That means taking the 8 is of no use. Secondly, I want closer, smaller element. So that means 8 will never be of use. So I will remove this 8. Similarly, 3 will say, if 4 is less than 11, I am also less than 11. If 4 is less than 100, 3 is less than 100. So I will say, taking this 4 is also of no use. That's what I've said. Just remove the previous greater element. Now, 3 will say, my stack is empty. What can I take? -1 only. I have no smaller element at left. Now, 3 will say just push me because obviously I can become the candidate ahead. Now 5 comes, 5 will say, okay, 5 is greater than 3. So it will say this is the smallest element that I get. Just take this index 2, okay, and take this 5 in the stack because this can become the closer element candidate for the next elements. Okay. Now I come to 3. 3 will say 5 is greater. Whatever. 5 is less than 11. Obviously, I am also less than 11. So obviously just remove this 5. Similarly, if I get 3, same number also. So obviously I will again remove it and add then push this 3. Obviously 3 will say there is no one inside there because all were removed before pushing 3. So it will be -1. And this is the previous smaller element indices that we got. Okay. So this is the approach. So basically what we have seen, like for every element, what we have done, that we were finding all greater elements and remove them because they will be of no use because whatever current element can do, that greater element whatever greater element can do that, this current element can also do that. Okay, this we have seen. Now every point we will check if stack is empty. If stack is empty, that means that means we have -1. No one is smaller at left. And if stack is not empty, just take the stack top. Whatever is smaller element, take it. So this is the approach. So basically, this question is direct variation of previous smaller element. This is a very common question in stack. Whenever we study the basic data structures of stack, this question is really comes. Okay. Now, similarly, what I want at every point I want previous smaller element, and at every point I want next smaller element. So with like the same thing, what I can do, I can start from the back and I do the same thing that if I get any greater, remove it. If I get smaller, because I am doing the same thing from the back. I want what? Like I have got the previous smaller element for every point. Now I will find the next smaller element because let's say I dry. Okay, to better understand. Okay, let's see that dry. So let's remove this, remove this, remove this. So let's create then another array next. Okay. Now we'll start from the back. Okay. To get the next greater element. Now I will say initially stack is empty. So I will say answer will be -1, or you can say anything. And you have to just mark the indication that no one is present at right. Okay. Now for next, next array, what it will give that at right any smaller element exists like this. Okay, we want to find the smaller element at right. Okay, so now we will say, now we come to 5. Now we will push 3 in the stack because we're going here. Now we come to here. Now I will say here is 5. So 5 will say, is this smaller? Yes. take this because this is closer. Obviously, 5 will be here, 3 will be here, 5 will say, okay, take this. Okay, now, now just take this. Now we'll push this 5 in the stack. Now we will come here to 3. Now we will say 3. You are smaller than 5. Yes, 5 is greater. Obviously, I can't take this. Just remove. 3 is equal. Obviously, I can't take this. Remove because I want smaller elements only. So 3 will say, okay, okay. Now stack is empty. -1. Just push this 3 in the stack. Now I'm again repeating again the same thing that anytime I get greater element, so whatever greater element can do, that smaller element can also do. And previous smaller element is required because this can be useful for ahead positions. Because 4 can't combat this, but 2 can accommodate this 3. This is the question. This is the approach actually. Okay. Now now 3 comes. Now when I come to 8, 8 will say 8 is greater than 3. So this is a closer element which is smaller than 8. So I will take this 2 and push this 8 in stack because let's say here is a 10. Here is a 8. So I will say if 10 is getting 8, why should it take 3? It will get because it have but my main aim. What is my main aim? My main aim is to get the smaller element that is closer. My main aim is not to get smallest element. Smaller, closer element. That means take the greater element because it can become the candidate. But but if somehow just see this thing, just visualize this thing like this: 10, 3, and 8. So I will say if 3 is smaller, obviously 8 is also smaller. If somehow 11 comes, so 11 is also greater. So obviously this 8 will be of no use anyway because 3, whatever 8 can work, 3 can also work. And I want closer. So why should I go far? I should come closer, na? This is the approach. Now, similarly, I come to 8, now I come to 4. 4 will say this 8 is greater, don't take it. Now 3 is smaller, just take this index. And now this is the array that we have generated. Now, after this array is generated, the whole thing is left if else conditions. Now, what was the if else condition that we have to maintain? First condition is that we have to maintain, we have to find the closest shorter distance that is left and right. Now, here is the indices. Now we can see previous not exist. So let's mark them cross because they do not exist actually. Now I will say it has no option. It will take 2 only. Why? Because it has no option. It has only next element. Okay. Now 1 has 2 option. Either it can go to 0, either it can go to 2. This distance is 1, this distance is 1. So I will say if the distance is same. So, and I have to take smaller heights. So 0th height is 4, 2th height is 3. So I will say smaller height is 3. So take this 2. Now come here. Now I will say no one is smaller. Just mark it -1. Just come here. Now I will say for 5. For 3 index, we have 2 at left and 4 at index at right, which is smaller, closer, smaller. Okay. Now this index, this distance is 1, this distance is 1. Now we will say 2th index height is 3, 4th index height is 3. I will say the same height is there. So I will take that index, whichever is smaller. So 2th is smaller, just take 2 now. Now I have -1, -1, -1. So you can see 2, 2, -1, 2, -1. So whatever we got initially, we are getting same answer as it is now. So final conclusion, let me give you again because this question is somewhat needs intuition and you need to practice such type of question again and again. So as to understand it, and you have to dry run by taking example test cases. Then only you will get it. You have to take this to your side also. Okay. So this question is somewhat like we have to remove the previous greater element because they will not be of use for ahead because whatever this greater element can do, that smaller element, the coming smaller element can also do. And if I'm getting smaller element now, why should I go beyond? If I am getting smaller element now, so I will not go beyond. But taking the previous smaller element is of use. Like in this test case, 3 will come. 4 will say that I am not smaller, but 3 will, but 2 will say I am smaller. So taking this previous element is of always of use. Okay. So let's try to code up the approach. Now, now we have array dot size. Let's store the array size in a n variable. Now we have two arrays as we are maintaining vector in previous, vector in next, which is storing the previous smaller element, next closer smaller element like this. Okay. Now we have stack. We are using stack. So now for every element, I will traverse. So first thing that I'm finding, find previous smaller element. So I will say traverse the array and then I will say until I'm getting greater element, just remove all of them. Just remove all of them. So I will say array of sc dot top. That is within the stack, I am storing the indices of the like elements indices. So I will say if array sc dot top is greater than array, or you can say is greater than equal to, because obviously I want smaller. So I will say just pop it out from the stack and add the end. If stack is empty, just like we have previous dot pushback minus 1. Else previous dot pushback previous dot pushback whatever is sc top, that is a smaller element, and at the end this element can become the candidate for next element. Just push this index into the stack. So within this loop, we will be able to get previous smaller element. Now we are going to get smaller next smaller element. Now next smaller element, we are going to traverse in the reverse direction. I get in 0, I minus minus. Now same thing we are going to do. Just copy paste this same thing. Same thing. Just instead of that, next dot pushback. And here will be next dot pushback. So this is the same thing that we're going to do. Now, one thing that this stack may remain filled after this iteration. So you have to erase this stack. So how you can erase this? Normal. If file stack not become empty, sc.pop, you can create new stack as well, but why to take extra space? If we are going to use same space, just it will take big of an iteration. Okay. Now I will discuss the time complexity, space complexity at them. Okay. Now after that, now just time left with, we have done previous smaller element, we have done next smaller element. Now what we have to do? Now you can see this when you are traversing the array in the reverse direction. So you are going to add the elements in reverse direction. Next array should be reverse. So reverse next dot begin, comma next dot end to make it straight. Okay. Otherwise you will get reverse next array. Okay. Now you have done this. Now we will make a vector int answer to store the answer. Okay. Now within this thing, what we are going to do for int I is equals to 0, I less than n, I plus plus. Now, now we will say we have two conditions. What? If previous I is equal to minus 1 and next I is equals to minus 1. That means neither left nor right. Means at both direction, no one is present. So just push back minus 1. Now you will see this is not included. It is included here. This is here. If there is no small on both sides, return minus 1. Okay. Now we will say if previous I is equal to minus 1. And like if previous I is equal to minus 1, that means we have checked this condition. Now, obviously at next it exists. So answer pushback next of I. Just take next of I. Else, if next of I is equals to minus 1, that means previous exists. Take it. Now at the end, that means both of them exist. So if both of them exist, we have some condition. First thing is I minus previous I is equal to, obviously if I have I, previous I is before, I is now, next I is now. So I will say I minus previous I and next I minus I to calculate the distance between both the nodes, means both the like left and right. So I will say next I minus I. If the distances are same, what we have said, pick the smallest tower. Now, now here comes. If two towers have same height, then we choose with smaller index. So we will say that if array of previous I is less than is equal to array of next I, that means previous height is smaller or equal. Take obviously smaller one because I've said smallest tower. Okay. And choose the one with smaller index if they have same height like this. Okay, so I've clubbed these two conditions less than equal to because they're working same. So I will say answer, not pushback, what previous of I. Else, let's remove these braces because otherwise they will become many braces. Else answer dot pushback. Obviously, I have no option. Just take the next of I because if its height is next I height is smaller. Now we have one condition. Next condition is if I minus previous I is less than next I minus I. That means previous distance is smaller. So if previous distance is smaller, so I will take previous element, obviously. My first priority is distance. Next priority is, okay. Else, obviously, Ahead distance is smaller. Take ahead distance. At the end, what you're going to return? Answer. So let's try to compare the code and check whether it's working fine. Okay, let's submit the code. So yes, it's totally working fine. So let's understand the time complexity of this question. The time complexity of the question is big of n. Why? Because here we are calling the stack empty. You will say that big of n for this, big of n for this. So it will become big of n square, but no. Stack will like push the element only once. So that means we are going to call this stack empty function for all the function calls big of n times only. Okay. Because every time you will add element, delete element, so you are taking the element only once, not for every iteration you are taking all elements, then you're doing that elements. So that means time complexity will be big of n and space complexity will be also big of n because stack is a linear data structure. It will take n elements. Fine. Okay. So the question was all about the basic things like previous smaller element, next smaller element, these two questions. This question is a club of these two questions and basically add then just if conditions. So this was all about code. If you like the explanation, please like, share, and subscribe to my channel and do comment that if you understand the explanation. So thank you and have a nice day.